Alright, welcome to Data Code. We'll talk about
AI, machine learning, data science, AI, data engineering, signal processing. Is that an orange? Computer vision, deep learning, AI, NLP, AI.
Alright, so in this video, we're going to be discussing a credit card default prediction project, which is able to take a credit card owner's financial historical data and then predict the probability that they will default on their monthly payments based on that personal information and financial history. Alright, so let's jump right into the code. Alright, so first of all, let's talk about the data. So this is the UCI credit card default data sets from UCI. Yeah. All right. So the data set basically has 30,000 rows of data and no missing values. All right. So that's basically it. And then, so let's jump right into the pre-processing aspect of it. All right. So experiment. Yeah. Here we go. All right. I'm just going to scroll all the way back to the top. Right, so here we can see just importing the different modules here. We just import the data, do like a head to see just like a basic view of the data from this side of things. Right, so you can see that this is the target column, default payment next month, 1 meaning default, 0 meaning consistent payments, right? So just some basic EDA check for unique values, check for null values, and then here's the a correlation heat map. So you can see here highly correlated values in terms of monthly bill amounts, and that's expected because degree of bill is going to depend on how much credit you've taken. So it's going to be a consistent amount for a given period of time, right? So that's what gives the correlated heat map between bill amounts. All right, so next we want to just drop a feature. I mean, ID, we're not going to be using ID here because we're not looking at specific individuals, we're looking at data patterns, right? So we want to check for categorical and numerical features to get those out because we're going to have to do extra pre-processing for categorical features, right? Yeah, just this plot, I was just trying to check the distribution and like how a particular because I was having issues with the model down below, but I was able to resolve those. All right, so now is the core preprocessing. I actually didn't use most of this because it ended up not adding so much value to the model. I was trying to just do some aggregation and some new features based on the existing features, but I didn't really do much, so I just skipped at those. Um, right. So now we use one hot encoder to encode the categorical features. So we have numerical representations for those in like a binary format. So for like something like sex, which is like 0 1, so we want to have just a column that represents the gender, right? And extend that to like education, um, marital status, and all other features like that. So yeah, I use for financial data, we expect that the normal transactions will be more than the faulty transactions, or in this case, the defaulters, right? So I used an undersampling strategy to kind of solve for that imbalance, right? This is a custom undersampling strategy, which actually undersamples based on the mean. It does like some calculations on the mean count of each of the features. So this function actually works for um, multi label target, not just binary situations, right? So because I actually just pulled this up from a previous project I worked on to solve for the imbalance here. All right, so now we go into the pre-processing. Oh, sorry, the train test split the model experiment, right? So here we did stuff like applying the transformations to split the data, drop the target column and all that. Then we scale the data. Now, something important here, I actually scale the data after splitting because scaling before splitting means that the scaler has insight into future data, right? So we don't want that. So scale on the train set and then apply the scalar to the test set, and that same scalar now will now be applied to data in production. All right. Um, Now use recursive feature elimination to check for the important features because now we have 86 features, but at the end of the day, I just used all the features because, like I said, looking for simplicity. If it was a more complex situation where we have maybe thousands of features, stuff like that, it would have been important. 'Cause, like in a different project, I actually had to use it because like it was the model was being too heavy, so I had to just trim down to the most important features. All right. That's that. So you can see kind of like what it's doing here: 50 features, 60, 70, 80. You see, all right. And here we just trained like a couple of different models. So this is like a dictionary, so I just looked through to train different models. Now, because it's a classification problem, I want to use logistic regression, spark vector, classifiers, just basically classification models, right? Okay, and then here, yeah, this is the test, like to see the performance of this one, and random forest actually performed best. Okay, so now I also did grid search. Yeah, but I really discovered that just the default for most of the models was basically the same thing. So I also did not get to use. Trust me, in other projects, these things matter more, but just for this specific data, I think the data is like just basically so direct that you don't need to do so much to get your answer out of it, right? Now I just tried to start organizing some of the functions here, but let's actually jump into the actual code because this is just experimentation. All right. So for the actual code, we go into SRC. So let's just start with utils preprocess. Let's start with preprocessing. Okay, so I use I modularized the code. Okay, obviously. I use functions now because I wanted to ensure that I don't have to repeat myself in training and in the inference side of things in production. So I just made a couple of functions that have dynamic behavior depending on whether we're doing train or test, right? Train or test, and test now. The test pipeline is the same thing as the um, inference pipeline, right? So a couple of models here to get categorical features, to fit the encoder, transform the data, scale the data, and the undersampling also. And we then have utility functions which organize these functions according to what we're trying to do. Are we trying to process a train input or are we trying to process an inference input? So it calls the functions a bit differently on both sides. For example, for the inference, we don't need to undersample anything. Um, and even when we're calling these categorical features, we're mostly loading stuff from memory as opposed to fitting things to the data, right? So that's basically it. And then we have okay, for the code now, we basically use login all through. Use a login all through because in deployment, you won't actually be there to be looking at your console print statements, right? It's not going to make sense. And also, um, it makes that there are records so you can check for what's going on later on. So I have log configurations for the three layers of the application. That's the train and test aspect of it, the server, which we'll get to shortly, and then the front end aspect of it, which we'll also get into shortly. So now that we looked at preprocess, let's look at models of pi. So this is where we just define that entire experimental aspect and now solidify it into what it's actually supposed to do. So we train each model, all four of them, and save each one, and then we test them afterwards. So that's basically what this is doing here. So now let's get to the server side of things. So here on the server, what we're basically doing is to check to see, what model has the user chosen, and then So we can load that from memory, and then we'll pass the data that the user has passed into the user interface, generate the prediction, calculate the inference time, and then return that in the response. Okay. Now for the front end, we basically have an option to, I use Streamlit for the front end. So here we have the option to upload data and everything. If you notice, I use try except blocks because we want to be able to catch errors and not have those errors break the code, right? So we want to catch errors to say, okay, what can the user correct to make this thing work fine, as opposed to the app just freezing or hanging. Now try except blocks. So we also validate the data that is brought back by the customer for testing. All right, so here's the validator. Where's that upload validator? Okay, so it takes the data, checks for all the expected columns to see that, okay, we have all the columns we need and they are in the correct data type, and we don't have any extra columns that we don't need, right? So we have those three basic checks going on here. Also, we have I've written some tests here, basically for the pre-processing side of things, the undersampling function, because that's like something I built. So I wanted to ensure that it consistently works as expected. So we have tests for when we have different classes and when we have the same class all through, right? We want to check that it functions as expected. Also, the upload validator, there's some tests here to check, does it behave as expected with valid data, with specific cases of invalid data, different cases of invalid data, right? So check for those. All right. So now we're going to go into the demo of the app itself. We want to just see how an end user can actually use this credit card default prediction app to generate predictions in real time for data. Well, not really real time now, but live, if you know what I mean, for the customer data, right? So let's spin up the server and the front end and see how this works, right? So I'm just going to go into the terminal, Control J, right? So Python, source C, Py, okay? So I'm spinning up the server. All right, so the server is up. I'm going to create another terminal here, and then I'm going to run the Streamlit front end. Streamlit run src. Okay, stream. That's supposed to be stream. All right. Okay. All right. So we have, this is what the UI looks like. So it basically prompts you to upload data. Now I limited the upload file size to 2 MB because, of course, if you're uploading just a user data, we don't expect it to exceed that amount. So even before the validator is called, the front end already checks what's the size of this app, of this file you're trying to bring in. So if I try to upload the entire data set, for instance, it will just flag it and say, oh no, the file must be very small, because that's what we expect, right? So now I'm going to upload sample user data, which is basically just one row from the data set that I've shown you earlier. All right, so now that we've uploaded it, it now pops up the option to choose the model we want. So you know that random forest was the best model. So let's just predict probability, and boom, it tells us the probability that this user will default is 90%. So it's like, oh, this user, from their history, they have a chance to always default in their payment, so it wouldn't make sense to renew their card or stuff like that, you know. All right, so that has been the credit card default prediction project. I hope you liked it. Just, you can also check out the full code on GitHub. I'm going to link the repository in the description to this video, and at the same time, we're going to have the documentation, full documentation in the repository. I'm going to add that before I upload this video, so you're going to have that there also. So just let me know what you think in the comment section. Is this project interesting to you? Would you like to see more videos like this? You know, the style of the video, what do you think would make it nicer? Because I'm just starting out, you know, so this, I'd like to have your take on this. All right, so this has been Data Code. Like, share, subscribe, like, share, subscribe, like, share, and subscribe. Thank you.